So let's take a fresh look at chapters 6 and 7. This checklist was actually given to you more than 5 weeks ago, and the quiz was actually administered on March 12th, and here we are a month later getting ready to either take it for the first time. I had 5 people miss the quiz on March 12th, and a few of you may be retaking it for whatever reason. We're going to take a look at all of these, but make sure that you know about the word expected value. This phrase, how many do you expect? That means mean. Take a real close look at binomial probability and these topics as well. This is normal distribution and the inverse of normal distribution. And then what do we do when we combine means or combine variance, or standard deviation? I happen to have Rachel's quiz here. Rachel, let's take your quiz. And we're so confident we're just going to do it in pen here. And I'm here reviewing this on April 10th. You, of course, will not be taking this exact quiz, but let's take a look at these questions. For those of you who are retaking it, you get a sense of maybe what you got wrong, even though I can't hand back your actual quiz to you because I can't get to you. A particular group of stocks has 3 different possibilities here, and the question here is to, by the way, feel free to pause this video and read the question a little more carefully. I'm going to rush through because I already know what it says. But what is a probability distribution? Right? It is laying out all the possibilities. There's the first probability. It has a 20% chance. There's the second possibility. It has a 70% chance. And there's the last possibility, and that is a 10% chance. Now, I kind of went backwards here, but we'll start with the negative first. There's a 20% chance that you're going to lose half of your $1,000. Losing half of your $1,000. So that's not a negative value here, but you know, we started with 1,000 and now we only have 500. 70% chance of the boring option, nothing happens, and then the 10% chance of the exciting option. And that's it. That's a probability distribution. You would expect to be asked what is the expected value or what is the average. And in so many words, that's what you're being asked here. This is not a subjective question. This is not like, well, how do you feel? In your opinion, what do you think? No, it's asking for an exact number. You should be able to calculate this. And we could do this by hand or on the calculator. I might do this both since it's fairly simple. If you just multiply these and then add them up, you'll get this fancy looking formula of the probability of each x times the probability of each x happening summed up. So let's multiply these guys, and here you get what is that, just a $100 value. Here you get $700 value, and here it's $200 value. Just multiplying these and then putting the answers there, adding them up gets, oh, nice round number. Well, that's what we started with, and at the end of the year we expect the exact same number. So this is actually the work for letter B, 1B. And if we wanted to put this in English, I would say I expect 0 change. Okay, not like, probably not. No, the expectation that is the most likely, or the mean value, is that you'd have exactly the same as you started with. Now, standard deviation, we could use a formula to subtract each of these values times its probability after you've subtracted the mean. Let's just do the calculator here. So in StatEdit, I've put the 3 possibilities and their 3 probabilities next to them. The thing is, when you do a stat calc, you'll just need to make sure that you tell your calculator you have a list too. If you don't do that, you will get the wrong answer. And sure enough, there's our mean of $1,000, and then there is no S because we're dividing by 0 there. The sigma is $387.30. Okay, the last part of this one question is, what do you mean by standard deviation? You should be able to define that. Standard deviation is the average distance of the values from the mean, or just the average distance from the mean. And there you have it. I think I'll keep going. I don't want this to be a ginormous video, but let me split it into two. Number 2. Suppose 75% of all drivers wear their seat belts. Make sure you read this carefully, and then oh gee, what's going on here? Okay, sorry, some focus problems there. I've written out the two formulas, mean and standard deviation. It's very important to point out that these are for binomial probabilities. So in case number 1, in question number 1, if you go back and look, you cannot calculate the mean by doing this. You cannot calculate standard deviation by doing this. This is only a binomial situation. If you need to look up what's required for binomial, please look those up in your notes. But in short, there's two possible results, independent trials, and we have a set number of trials. So this is as simple as multiplying these two numbers together. So this is 5 times 75. So that's 3.75. Okay, now it might bother you that this is discrete data. We're talking about people, drivers, but this is an average. So it's okay to have a decimal as an average. And sometimes people multiply everything by 100 and say, well, what does that mean? Out of 100 drivers, whatever. Actually, I don't want to mess this up. This is out of 5 drivers, it'd be 3.75. So that'd be out of 500 drivers, you'd expect 375. But it's okay. I just reiterate, it's okay to have a decimal for discrete data when we're calculating mean. Do not round this to 4. That'll be inaccurate. In a random sample of 5 cars, find the standard deviation. Well, we're going to take those two numbers and throw in Q. What is Q? It is the complement. So if this is 75%, then Q is 25%. And we'll just say that equals the square root. That's of the 5. The order doesn't matter here, but I am changing it. Okay, and you put that in your calculator. You find that's a little less than 1. Let's put it into 3 significant figures to be precise here. Okay, what is the probability that exactly 3 of the 5 cars randomly sampled would have people wearing their seat belts? Well, we need an N, we need a P, and we need an X. And these would go into the binomial formula, but we do have our trusty calculator, so let's get that out and punch those numbers in. What are we talking about here? Distributions, so we want second vars to get different probability distributions. And if you go up to binomial PDF, why is it PDF? Because it's exactly 3. We're not talking about 1 and 2 and 3 or adding them together. Number of trials, let's get this right. We're talking about 3 of 5, right? So we have 5 trials. It's always 75% chance that a driver would be wearing a seatbelt. Exactly 3. This is going to put those values into the binomial formula for us, and we get something a little more than 25%. So we'll call that 0.264. So in a quiz situation, you would need to write down what was on our calculator here. Binomial PDF. put in the 5 and the 75 and the 3, and that gave me this value. Okay, that's very important for anyone going behind, like me, going behind you and figuring out what you did. I can see what went into the calculator there. In a random sample of 5 cars, what's the probability of no more than 3? No more than 3. So, there are these. Here's the list of possibilities here out of 5 drivers. You could have 0 wearing a seatbelt. You could have all of them wearing a seatbelt. Where is no more than 3? No more than 3. So 4 is more than 3. We're not going to count that one. But we're taking this probability, this probability, this probability, and this probability, and adding them up. So we are going to use the binomial CDF function on our calculator. If we were doing this by hand, we'd do it for 0, write that number down, and then add up the results, 0, 1, 2, 3. Which is kind of a lot of work, right? So we're glad to have this trusty machine here. So I will go back to distributions. This time choose B, CDF. Put in my 5 trials. Put in my 75%. And then here's where I want to just double check myself. No more than 3, right? So I want this to keep adding. And once I've added 3, I'm going to stop. So CDF is telling where do you want the calculator to stop adding, and sure enough, it's going to be at 3. Now, if this were greater than 3, we would take the complement. We'd get 4 and 5. If it was at least 3, we would stop at 2, take the complement of that value. But here it is, no more than. That includes 3, 0, 1, 2, 3, and that gives us 36, 7. So these were indeed the same values. And this answer was 36, 7. Find the probability of the first. This is, when you see first or until, then you know that this is a hint. Geometric. Geometric. Now, you could just think this through if you didn't know anything about geometric probability, right? We're going to say, okay, there's the driver number 1, driver number 2, and then the third car has the seat belt. So we're going to put an N for not wearing, and then finally an S for wearing a seat belt. Well, what's the probability that you see someone not wearing? 25%. And then again, 25%. And this is the geometric formula. So you take Q, the probability of it not happening. You multiply it not by X here. We're looking for 3 until we find success, but X minus 1, right? What do we call this? N minus 1. But it's 1 less. And then there's just that 1 chance. So we don't really need to put a 1 there. But that is the formula for geometric probability. Or you could just think it through, right? No, no, yes. So you multiply these guys together, and you get 0, 4, 6, 9. You could, there's a calculator function for that, but I think the PDF for geometric is kind of a waste of time. Now, if you needed cumulative, then you might go ahead and use the calculator for that. Okay, here comes that question again. How many do you expect? Or what are they asking for when they say how many do you expect? That is the mean. And what is the formula for mean with geometric? Okay, and this is the geometric mean. Okay, not the binomial mean. We have the formula for binomial mean right here. N times P. This is quite different, isn't it? So it would be nice if we just had this in fraction form. P is actually 3/4. Yes, you could put in 0.75 and ask your calculator what that is. But if you just know it's the reciprocal of of your probability, then you know it's 4/3. Try it. If you don't believe me, do 1 divided by 0.75, and you should get that. Okay, and don't be bothered again that it's discrete data. We're just talking about a mean. Most of the time we expect 1. Why? Because it's a 75% chance that we'd find someone wearing a seatbelt. But since it's not 100%, so there are, on average, it's going to be more than